On this week's NFV SDN Reality Check, we look at some of the top news items from across the space, as well as speak with Accedian Networks about network QoS related to SDN, NFV, and 5G. Well, thanks for joining us for this week's NFV SDN Reality Check. I'm your host, Dan Meyer, Editor-in-Chief for RCR Wireless News. On today's show, we have an interview with Scott Sumner, who's the VP of Solutions Development and Marketing at Accedian Networks, on network quality of service needs and challenges related to NFV, SDN, and 5G technology deployments. But first, let's take a look at some of the top headlines from across the telecom-related NFV, SDN, cloud, and software space in the past week. Speaking at this week's Open Network Summit, AT&T's Chief Strategy Officer, Donovan, provided an update on the carrier's virtualization progress, which is set to see 75% of its network controlled using SDN and NFV technology by 2020. Donovan reiterated the carrier's previous comments that it had hit 5.7% control at the end of 2015, which was ahead of its forecast of 5%, and was on its way to 30% control this year. Donovan highlighted AT&T's success is now supporting 14 million mobile customers on its fully virtualized mobile Packet Core, with millions more set to be migrated this year. Donovan also said the carrier was set to begin a trial using the ONOS project's core platform, with the carrier stating the move would be used to accelerate the rollout of its gigapower broadband service. Showing AT&T's continued innovation across the NFV and SDN space, Donovan also touted the carrier's work on its enhanced control, orchestration, management, and policy project, dubbed eComp, which AT&T said is designed to automate network services and infrastructure running in a cloud environment. Donovan said AT&T has been working on eComp for nearly 2 years, tackling the project due to a lack of guidance for NFV and SDN deployments in a wide area networking environment. eComp is said to provide automation support for service delivery, service assurance, performance management, fault management, and SDN tasks. The platform was also designed to work with OpenStack, though Donovan noted it was extensible to other cloud and compute environments. AT&T released a white paper on eComp in a move to garner commentary and support for the initiative, and said it was amenable to releasing eComp into open source, following up on previous comments to support the open source community. Also this week, Ericsson and NEC highlighted their work with NTT Docomo's recently announced multi-vendor NFV platform. Ericsson said its platform is based on OPNFV network architecture and was used for NTT's commercial service launch late last week, which the vendor claimed was the first of its kind. Ericsson said it also provided system integration and support services for the deployment. The platform is said to provide interoperability and connectivity with any carrier-class VNF and SDN solution. NEC said the NTT deployment included its NFV solution made up of its virtualized EPC and VNF manager. The virtual EPC is said to virtualize the LTE core network functions, including the mobility management entity, serving gateway, and packet data network gateway, with a VNF manager from NEC's subsidiary Netcracker handling creation, activation, termination, and updating of VNFs. Well, for this week's featured interview, we spoke with Scott Sumner from Accedian on network quality of service needs and challenges related to software-defined networking, network functions virtualization, and 5G technology deployments. Let's take a look at that interview now. Well, thanks for joining us today. Today we're joined by Scott Sumner, who's the VP of Solutions Development and Marketing at Accedian, to talk a bit about quality of service issues and in terms of how it relates to this move by telecom operators to SDN, NFV, and even 5G, and just the different network evolution. So, hey, Scott, thanks for joining us this week. We appreciate it.
Hey, thanks, Dan. Thanks for having me here.
Great, very good. Well, maybe to start off with, let's have you give a little overview of Accedian for those who maybe don't know much about the company, maybe what you guys do, and how you kind of participate in the telecom space.
Sure. Well, I guess we're turning into our 12th year here at Accedian, so we're a fairly mature provider of network monitoring equipment and performance assurance equipment. And notably in the mobile space right now, we're used by about 85% of the top 20 mobile operators worldwide to assure their performance of their network. And probably a little known fact, because monitoring isn't something that people see a lot, it's sort of embedded into the network. But in the States, we're covering about 50% of all mobile traffic is going through our devices as a way to monitor and assure performance there.
Got it. Makes sense. And obviously, like you said, it might not be a very well-known part of the network, but again, with data traffic growing like it is and video traffic on these networks, it has become a very important part of what's happening out there, because obviously operators are always trying to stay on top of their quality of service levels. That's always a big part of the market. I mean, it's such a competitive market that they have to make sure that. It does seem like what you guys are offering in the market has become a very important aspect of what operators are trying to do in terms of keeping that quality of service while still allowing customers to do, all their video streaming and things like that on the market, it seems like.
Yeah, I think you're right about that. I mean, we've seen, if you look at the States, all the competition that T-Mobile introduced, pricing wars, the extra free plans and zero-rated content. What we're really looking at there is a race to the bottom in margins. It's really hit them hard, and the operators have a hard time financing the future networks with that kind of lack of monetization. So when you look at that, really quality of experience is their last main differentiator that's inside their control right now. So a lot of them are focusing on that. So it used to be, 3 or 4 bars was imported. Now it's really about, VoLTE, the experience of using a mobile network versus an over-the-top service. And how can they really create some stickiness with their customers that they become dependent on exceptional user experience.
Yeah, it's a great point there. Well, obviously now we kind of touched on at the beginning there different technologies that are coming along here. And one thing we talk a lot about on this show is the NFV and SDN kind of virtualization space. So as we look at that part of the network evolution, how is that impacting what you guys are bringing to the market, or what you're seeing in the market in terms of what operators are looking for in terms of their QoS solutions that are being deployed out there?
I think, a fundamental change being introduced here with SDN and NFV, and we know that 5G networks are going to make that happen just because of the complexity that's going to arise and the need to use spectrum and resources efficiently. But the virtualization of the network functions in SDN, really what they do is change dramatically the traffic patterns in the network. So if you talk about these network slices, the ability to separate applications from each other, there's also this need to route based on application awareness or bring traffic over paths that are optimal for specific use cases. And what that really means is that the traffic is no longer going to pass through the EPC anymore. The core will be no longer a complete gatekeeper of everything. There's going to be a full mesh distribution of traffic going from site to site, user to user, base station to base station. And that's where quality of service becomes a lot more difficult to control, just because you don't have the visibility from any central analyzer anymore. They can see what's going on.
Yeah. Oh, I mean, I guess for your solutions that you're providing, I mean, I'm guessing you guys have had to alter how you offer your service, your platform to operators, because obviously in the legacy situations, it was fairly easy. Put some probes in there and you kind of see what's happening in the network. Where it seems like with this move towards virtualization, I mean, obviously what you're offering is somewhat software based, but I'm guessing you guys have had to kind of adjust a bit to, I guess, this new dynamic of operators looking at least forward towards virtualization in their networks.
I think that's actually the main reason why Accedian's had such a great year last year, really growing close to 30%. This has been a continuous growth wave for us, but it's largely because we started virtualizing our solutions ourselves a number of years ago. And in the RFQs and in the bids we're seeing for monitoring equipment today, the demand is that it has to be fully virtualized. There has to be basically no equipment installed in the network from a monitoring or probe standpoint, so you can spin up new instances of these virtual probes instantly. Also to allow for faster deployment times, right? It used to be that you'd instrument the network with probes. You might be doing this for 6 months to a year. Now we're seeing tier ones covering 40,000 cell sites in less than 3 weeks, and it's really just a matter of orchestrating these virtual network functions that do performance assurance, the same way they spin up virtual network functions for other reasons.
Yeah, well, I mean, how much of that was extra work for you guys last year? I mean, obviously, it sounds like you guys had a great year last year, but I'm guessing having to kind of make that adjustment and make things more adaptable to this new world. I'm guessing for you guys, it was probably quite a bit of work behind the scenes to make all this stuff kind of evolve with what operators are asking for out there.
It's you'd think it would be a pretty insurmountable challenge. I mean, a lot of other monitoring equipment vendors probably had to start from scratch and build a new architecture for a virtual solution. We were pretty lucky in the way we designed our solution to begin with, that we had separated the data plane from the control plane, and the control plane was running in Linux. So when we took that and sort of separated the two, the control naturally fit into a virtual appliance. So we didn't have to rewrite an awful lot of code. We just had to make sure that when you separate these functions, let's say traffic generation from its actual control source, that they have the integrity of working on a seamless network together. So it's kind of like taking a hardware-based solution, chopping it into two, and making sure there's a seamless connection between them. And once you can do that, you kind of virtualize the data collection points or the probing points to hundreds or thousands of locations in the network with a single centralized virtual CPU handling it all. For us, we were kind of lucky. We were already on a Linux base. We had all our own technology, and the data plane was already separated. So I think that let us come out ahead in a lot of offerings where maybe 2 years ago, we didn't hear this kind of request for a fully virtualized solution that you have to deploy in weeks. But in the last year, that's been increasingly probably the majority of the opportunities we're seeing coming across to us.
So obviously, at some point in the past, there's someone there at Accedian made some good decisions how to kind of line everything up on the network there, which obviously made it much easier for you guys over the past year than to kind of be ready for this.
I think it's more a mistake or good luck. Because actually, when we were back at Supercom, I don't know if you remember way back 2003 or something when we started out the company. There was a prototype there, and we were in a showcase of emerging technologies. And this prototype of our network interface device was an FPGA-based device with a CPU that ran Linux. And at the time, the CPU code wasn't ready yet. So they were running it in a laptop and connecting it into this box, making it all work as if it was one single device. But in the end, that was actually the same architecture we return to today. Having the CPU and those calculation functions separated in a virtual machine is actually the same way we built the architecture 12 years ago. So I think it was probably elegant at the time. It certainly helped make some good demos, but it's probably a bit accidental that all these things happened and led us to a state where we can do this with almost very little effort. And I think the real key point there is if you're starting over and you're building a whole performance monitoring stack from scratch, you're not going to be bug compatible with all the stuff you've already done. So you're going to end up rewriting a lot of things. You're going to run into scalability issues. You're going to learn some hard lessons, and there's going to be a lot of time where you're kind of in traction trying to get your feet on the ground. And I think that's this is not the time to do that when operators are trying to move to much more advanced technologies.
Yeah, very interesting. Obviously, bringing up Supercom just kind of shows the fact that, a lot of the parts of the telecom market do tend to be kind of cyclical and always seem to come back at some point. So, it's always fun to hear that. But, interesting. Well, I guess, one thing you kind of brought up there is obviously it does seem like in the virtualization space and, with technology right now, I mean, there's still the standards issue going on where, the technology is moving so fast and evolving so rapidly, and operators want this on their networks yesterday as opposed to, waiting for this. It does seem like that standards issue has become a bit of maybe a sticking point or a hurdle because, again, you want to make sure at the end of the day that everything can kind of work together and that there is at least some sort of common language to everything. Has that at all impacted what you've been able to do? I mean, because it does seem like we're still in this part where, we are still trying to find what these standards are going to be. Etsy's working hard on this stuff, and a lot of organizations are out there working, trying to kind of bring some groups together. Are you finding that's been a bit of a challenge for you guys in trying to, kind of meet what the operators are asking for out there?
It's from a instrumentation standpoint, I find that it hasn't affected our ability to really execute or scale. Okay. We get our devices into virtual appliances, but they're not necessarily part of the actual service chain. They're actually above it, right? They're at a layer between the data plane and the SDN controller. Mm-hmm. And what they're using them for is really to feed back the network state information, the quality of experience into the SDN controller and the analytics platform so they can make decisions. Now, all those other aspects are virtual network functions that need to be chained together. And that's where, of course, their sticking point is. But in terms of orchestrators and things that need to be brought into the equation to do that, when we work with a lot of operators that have managed to create a fully virtualized, CRAN or a fully virtualized EPC like SK Telecom and a lot of the operators in Japan, they've designed their own orchestrators. They're not waiting for standards, and they are using open source as much as they can. They're trying to influence the standards, as you'll see. A lot of them are involved directly in those open source and standards bodies. But of course, they couldn't wait for that to happen. So the thing is that even though the standards aren't necessarily there and they had to do it themselves, they were actually successful. And what I think is a very important message to the market there is that this can be done at scale. It can be done very efficiently and within a couple of years, right? Which is actually a short deployment cycle compared to physical equipment upgrades. For the telecom space, a couple of years is lightning quick. I mean, in the past, we've seen, technology evolution changes have taken, a decade or so. But what's happening now is happening rapidly. And it does seem like, like you said, I talk to a lot of companies who are kind of on board with open source and all these open source organizations. It does seem like, at least if you're going down that road, it does make perhaps these early deployments a little more tolerable, or at least a little more future-proof in the fact that, those things can at least be worked upon, and everybody seems to agree at least that open source, for the most part, is kind of the future of where we should be going with this. I mean, obviously there's some larger vendors who, want to keep some stuff proprietary, but that's for a future fight down the road. But it does seem like at least open source has become a pretty big part of this move towards virtualization by telecom operators. And I think we're fortunate enough that there are at least enough standards in certain areas that constrain what you can do, right? So if you have the 3GPP standards out there, you've got on the instrumentation side, we have all the standards already developed in the IEEE and the ITU. And a lot of these protocols and metrology telemetry standards are already baked into a lot of the base stations, a lot of the routers. So if you look at some networks that would have, Juniper and Cisco routing combined together, several different base station vendors, 90% of the time they all speak the same test and measurement protocol. So from getting a consistent, reliable view over a multi-vendor network, that's actually quite feasible and possible based on standards today, and comparing those to the metrics of what's required, right, in LTE network and what the baselines are going to be. So you can get that viewpoint. And I think if you have a consistent metrology viewpoint across the life cycle of these new service introductions, you can detect what's happening as you start to change. So if you start introducing new open source components, if you start moving your VNFs around, if you start to employ, new spectrum, millimeter waves, whatever it might be, at least you have a consistent heartbeat of what the network's doing, and you know how to correct that very quickly, which is, of course, the advantage of being in a software-based environment, right?
Yeah, that makes sense. Well, one of the things you kind of brought up initially in your kind of overview of what you guys do there is obviously, this move towards VoLTE by a lot of operators. It seems like it's pretty well underway. A lot of operators have commercially launched their VoLTE services. The next step is kind of interoperability between these networks. But at this point, it seems like VoLTE is coming on pretty strong. And a lot of these deployments are using a lot of virtualization or being kind of segregated off from the network that way. But again, the quality of service aspect seemed to have been, or maybe still is, one of the trickier points of VoLTE deployments, because again, consumers have a certain expectation when it comes to voice services. The legacy circuit switch voice, while maybe it wasn't optimal, people got used to it. They got used to not having a dialing tone and things like that. So now it seems like this move towards VoLTE. I've used it on several occasions, and it's, when you first use it, it is a bit shocking how clear it can be. It almost doesn't sound right because you're so used to kind of the older way of things. As you look at that aspect of kind of the quality of service issues, I mean, what have you seen in terms of ensuring that VoLTE is ready to be out there, and that operators are able to kind of really match that quality, because again, voice is still the bread and butter for a lot of operators, and that's something that they don't want to lose from their customers' perspective.
Yeah, we've seen an awful lot of false starts on VoLTE deployments. I mean, people triumph for the ones that work out and sound good, but I think a lot of operators raced into it, and like you're saying, a lot of new technology here, a lot of virtualization, a lot of localized VNFs, and so you end up with a very complex chain, right, that goes between the end callers to each other. It might go through virtual appliances, different network pieces, and so on. And I think it also forced operators to start tiering their network traffic a lot more. So they had to really create a class of services that would carry that, including the signaling separately, so that they could really maintain call quality. That said, the ones that were successful really started out by assessing their network, right? They came up with some sort of bottleneck plan of where they might have to upgrade, so they make sure they got the latency down, for one example. They can increase capacity and test out and simulate the services. And one thing they learned along the way, I guess, was you have to not only monitor now the call itself, or the quality of the call, or the transport, you also have to measure the quality of the connections between the virtual network functions themselves. Right? So the fabric of the actual service chain needs to be monitored continuously, so you can move things around, things go wrong. With all that today, we still see the metrics on VoLTE being much worse in general than standard telephone calls. Not on the audio quality, because that's kind of a given that it's a better use of spectrum and higher quality, but on call drops, for example, they're still about 40% higher than standard cellular calls. And the bandwidth impairment to other applications while VoLTE is running may actually be significant depending on the burstiness of the call. The big problem that we see from our perspective is that about 80% of all call failures occur in the RAN network. So they're in the backhaul, they're in the radio side. And all the analyzers that have been used today, the ones that look at VoLTE and policy enforcement and signaling and all that stuff, are all at the core. And that's a problem, because they can detect what's going on, but they don't actually know exactly where it happened. So that's really where the problems are going now. I mean, I think we're seeing the virtual functions distributing widely, so I think we're also going to have to see instrumentation, including our own, starting to also distribute, kind of sprinkling it throughout the network and allowing access to this information that would normally be at the core, but now is more important to see everywhere else but the core.
That's a great point. You're right. I mean, it does seem like that the need to have kind of that quality of service measuring. You're right, all through the network, because I mean, if it's happening somewhere where you can't get a lot of details of what's going on, it's slipping through the cracks there, and you don't know how to fix that problem. And you're right. I mean, it does seem like VoLTE provides or brings so many signaling issues onto a network, and so many various things that operators are struggling with. And, I've talked to a lot of operators about this, and that's been, they were a bit challenged by this, and it brought up a lot of new issues that they didn't even think about before. So yeah, it seems like being able to kind of sprinkle that all through the network now, as opposed to just in certain areas, is going to be a big part of kind of this continued evolution of the role of VoLTE.
Yeah, I think the problem there is you can't really bring the analyzers to those locations, right? If you're looking at some of these DPI analyzers or VoLTE analyzers, not solutions we sell, but the ones we interface into, they can cost hundreds of thousands of dollars, and it'd be very difficult to even think about virtualizing something that powerful at a cell site, and you'd have to do that at every cell site. So the solution we came up with there, and we're actually at MWC next week partnering with Sandvine to show this kind of solution, is we've made a remote capture mechanism where we can capture data flows from anywhere in the RAN network and bring it to the analyzer that's already centrally installed. So they get this kind of location-based awareness, and they can solve problems that we've all had many times, call quality problems like one-way audio, for example. You can hear me, but I can't hear you. Those kind of things tend to degrade as the call distributes through the network. And if you're looking at that from a central location, you would probably say that the call sounded okay, but except, by the time it gets to you, the call is almost dysfunctional, right? So these issues are now able to be detected. And the nice thing is a lot of DPI vendors and solutions like Sandvine actually have location awareness capabilities built in their analytics. They just need access to the data. And then they can say, okay, I see the same call at 7 or 8 points along the path. I know now what's happening, and this one router is causing all my problems. At least they have some actionable metrics to go and fix it. So that all said, I think we all understand VoLTE is just one application of that type, right? When you say, well, VoLTE is causing all this change in the network and virtualization and different ways to instrument, that's the first application, right? Wait until the IoT comes in there, wait until you start getting into telemedicine and health and connected cars, and all these things have exactly the same demands. They're all distributed, they're all widely different in terms of their performance demands, and there's no analyzers that can distribute out there. So it's going to be a really wild place to live in a little while, the network.
Yeah, that's a great point. And that's probably a good time to kind of bring up, looking even farther ahead, because you're right, when it comes to, the move to 5G and IoT and all these different things, it does seem like that those are going to bring so much more traffic onto the network. And operators, obviously they're talking a lot about 5G and IoT and how they're going to be, supporting it and ready for it. But it seems like even just with the VoLTE deployments being perhaps a barometer of what's happening out there, that maybe they're not quite as ready as they might be. Obviously we're still years away from a lot of these things. But at this point, it does seem like we're still pretty far away from being able to really support what could be coming out of the networks. I'm sure for you guys looking ahead, I'm sure that the opportunities have got to be immense out there. And I'm sure, your discussions with a lot of operators and vendors on making sure that these networks are going to be ready. As you view those, what's kind of your biggest concern looking ahead of, making sure that you guys can support what is going to be, everybody talks about kind of the tsunami of data coming on the networks. How do you guys do that support there?
But it's really about being able to see multiple classes of service and multiple applications distinctly on their own and being able to measure that QoE in real time, right? So you can feed this into something that can fix it. And the three foundational pillars of the SDN networks that are going to control 5G are basically based on the trend, or motivated by the trend, that there's going to be 10 times more apps on your phone, according to the GSMA, 100 times more devices in a network within 3 years, and 1,000 times more traffic. And if you sort of multiply all that out together, you're talking about 1 million times more complexity in terms of the amount of sessions and packets and things you're going to have to manage. So the conclusion there is basically, okay, the network is going beyond human ability to control it. Makes
automation's got to be key for that. Yeah, automation.
Yeah, devices on IoT outnumber us by the end of the year in terms of population. Of course, we're not going to be able to control this easily, but there are tools out there, right? The analytics tools, there's the SDN controllers that have intelligent deep learning. You've got the instrumentation layer that can bring this feedback in like a nervous system. So I think that's kind of how the network has to evolve. Our solutions have to evolve to instrument more points at basically no cost, so you can see everything immediately. The SDN control systems have to take their feed from analytics that are learning from their own mistakes and their own corrections. And then you have to be able to distinguish every application separately on the network. And VoLTE, by the way, isn't even one of those, right? In 5G specs, they came up with 3 classes of actual use cases they're trying to address. That would be, ubiquitous machine-to-machine communication, so basic machine-to-machine sensors. Then they have the ultra-reliable IoT for like health and critical safety, which is a totally different thing. It's a low latency. It's got no packet loss allowable, and has to be always on. And then you have the enhanced mobile broadband experience, which is also not supporting the VoLTE case, which is actually a hybrid of all of those, right? It has to be very precise, very low latency, but doesn't take a lot of bandwidth. So what we're seeing is four or five types of classes of applications as a minimum. They're going to share the same network. So things are going to get very interesting, and I think the visibility is sort of the right place to start in terms of addressing that.
Yeah, I mean, you're right. I mean, VoLTE is almost that's a 4G problem there. It's not even a 5G problem. I mean, VoLTE's got to be done before all this even starts taking place. But yeah, it does seem like that the market out there is going to be in for a bit of a shock. I mean, I guess as you look ahead a little bit there, I mean, how prepared, maybe from the vendor perspective, are we for supporting what's coming down the road, do you think, at this point?
Yeah, I think, well, if you look at the 5G standards and everything coming out, I think it'll probably catch up just in time for people's expectations. If you look at the ITU and the 3GPP and GSMA, they're making the standards for 2020. They're on track for that. Yeah. But there's only a few unknowns in there. For example, they have to figure out entirely new radio technologies in the next 2 years. So will they do that? I mean, it'll probably happen in one way or another to support the base use cases and get rolling out. But I think the real shock is going to be the difference in the ability for a mobile operator to survive under that onslaught of traffic, between the ones that kind of keep enhancing and growing their static type networks, larger and larger, more and more capacity, versus the ones that decide they're not going to just take a brute force approach. They're going to build an sort of intelligent architecture around it that can adapt to what the network is undertaxed with at a given time. And I think we're going to see by 2020, 2022, that kind of time frame, that the ones that put their time into making their network intelligent are the ones that are going to come out far ahead in terms of quality of experience. And then you have guys who are suffering with VoLTE today. Well, they're going to be in pretty serious problematic situations when you think of all the other traffic that will overwhelm VoLTE by that time, if they haven't figured out a way to corral these things, organize them, and monetize them separately.
Yeah, that's good. I mean, does it seem like operators are aware of that? Because I mean, there's a lot of smart people working on these things, and lots happening behind the scenes, and things tend to kind of work themselves out, it seems like. But again, this is evolving so rapidly, and there's so many changes coming to the network now with virtualization and all these different technologies coming out. Does it seem like, from your point of view at least, that the operators are aware, and that will they indeed kind of all meet up at the right point, and everything will be, end of the day, it'll all be fine?
I think some of them are it's a funny question. Yeah, you're right. It's a bit scary when you look at some tier one operators we work with are still migrating 2G to 3G, and depends on the region of the world, and they're using base stations from late 1990s. And so are they ready? I mean, maybe they're in a position to leapfrog. But one thing I think is interesting is you look at the operators in Korea, Japan, China. They're sort of down this path to a larger degree than a lot of the rest of the world. And you see AT&T sort of blazing their own path here in North America, and they're following the same formula. They're all following the path. The ones that have proven success are kind of like the ones that validated that the other people have made the right choice, or the other operators are on the right path. I think they'll all end up in the same place, because there's only really one formula to be able to achieve the overall architecture that's required for 5G. So it's a question of where are they on that journey, and have they acknowledged that they're going to have to do that. At some point, their networks will be overwhelmed. And if they're not prepared to take on that elastically and dynamically adapt to it, they'll be forced to make that investment at the time when it happens, or they're going to lose subscribers till the traffic gets low enough that they can handle it, right? So it's a question of not how they're going to do it, because I think we've seen from the leading operators, Docomo, SoftBank, SKT, all these guys have demonstrated exactly how to do a 5G network, and that it worked, and it's very cost efficient. AT&T is following the same path. So if people follow the formula and pay attention to the lessons learned, they're going to do fine. By the time they get there, if they're late adopters, the technology will be more mature. It should be a little easier for them. So I don't have any doubt of where we're going, and I don't think the operators do either. It's just a question of, are they ready to take that step, or do they have to do a little more, cleaning up their existing network, solidifying things, and getting the right resources in place to start working on that.
Yeah, that's a good point. Yeah, and it does seem too, I'm guessing for the vendors out there, that it does seem like it's kind of nice to have operators really asking for this, as opposed to, I mean, like I said, in the past, it was always vendors pushing their solutions to carriers saying, hey, you need this, you need this. Now it seems like, this move towards virtualization and 5G, it's a lot is the operators kind of asking for this. I mean, it's, obviously AT&T here with their domain program, really bringing people together, and SK Telecom and Docomo. I mean, they're really kind of pushing this, almost saying, hey, vendors, this is what we need. Help me get to this. So, I mean, it's got to be, from your perspective, a nice change from what's happened in the past.
It's nice to see this pull on instrumentation, because normally it was seen as an insurance policy or a necessary evil, but now that it's actually driving feedback into the actual network control, it's becoming foundational, right? The problem is that these operators are right. You're right. They're smart people. They're thinking in advance. They're asking us for the solutions, but they're also they're tough customers. They want this to work now. They want to be fully virtualized. They want to be scalable across millions of subscribers, and they want to do this in a few months at production levels. So they're making us a better company, and
well, that's one
benefit, right? That's the whole point. We'll probably survive it and have a better offering to give to all the others that are ready for that. So I think we split our time between solving problems in legacy networks, and the same solutions are basically steering traffic through the most advanced pre-5G networks in the world. Yeah. Amazingly, at least it's the same solution, or else we'd be really torn apart.
Yeah, well, that's a good way to look at it. Obviously, it makes us, obviously it's painful now, but it'll make us all better in the end. So just like our parents said when we were kids. So it's a bonus.
I don't know why everybody tells me that now, but they never told me it would be this tough.
Well, again, I'm sure, I'll keep you guys busy. I'm sure a lot of long weekends and long weeks for you guys there, but it's been an interesting couple of years, that's for sure. But Scott, again, this is a topic I know we could probably discuss for another couple hours. I know we were talking about that earlier. It's the fact that this is something we could discuss on and on and on, but we'll try to keep it somewhat short for our viewers here. But again, I definitely appreciate the insight on this today. And again, as this kind of evolves and moves along, I'm sure we can touch base again soon on this, but again, we definitely appreciate the time and insight today. Thanks so much for that. Well, thanks for joining us in this week's NFV SDN Reality Check. And make sure to check us out again next week when we will have more news from the ONS event and schedule to speak with Quartus to get a primer on mobile edge computing. Thanks for watching.
NFV SDN Reality Check with Dan Meyer is a production of RCR TV. To suggest show topics or to reach Dan, you can find him on email, dmeyer@rcrwireless.com, and on Twitter @Meyer_Dan. For more Dan, news on NFV SDN and everything wireless, find your way over to rcrwireless.com.